Good day there. Our class today is our online class today by Gag Edit Consult, anchored by my able self. Today we are going to be looking at an interesting aspect of chemistry, which is the periodic table. The periodic table. And the objective of this class is to look at the following. What is a periodic table? Secondly, we are going to look at how elements are classified, the classification of elements. Obviously, we all know that the periodic table helps in classifying elements. If you're looking at periodicity of elements, you know that, well, for an element to be arranged on the periodic table, you have to have the understanding of the atomic number or the proton number. The proton number has a relationship, has something to do with the number of electrons. All about groups and period. Then we'll be looking at metals and non-metals as time goes on, transition metals, and what do you have? What have you? Patterns and trends in the periodic table, which is the most interesting thing that we are going to look at. Looking at this overview of a periodic table, you can look at this periodic table, beautifully spaced out. You know, the work of a great scientist, a Russian scientist, Ivanovich Dmitry Mendeleev, was able to, in the 18th century, to gather elements together, doing his work just to make life easy for his students. So he was able to get different elements and even predicted the names of these different elements. So the periodic table is just a summary of chemistry. It names the elements that makes up our world. So on the periodic table, every element that you can think of in this world is on it. There are 119 elements on the periodic table. 90 of these elements are naturally occurring, which means that the remaining ones are artificially made. They are man-made. Looking at the groupings, you have the alkali metal, the alkaline earth metals. You have those one between group 2 and group 3. You have the transition series. You have the chalcogens, the halogens, and the noble gases. These, then you go to the other block. You have the F block, which is comprising of the actinides and lanthanides. So, what can we say about the periodic table? It's just the arrangement of elements based on their atomic properties. The periodic law even states that the periodicity of elements are a periodic function of the atomic properties. What that simply means is that elements are arranged on the periodic table following the atomic number and the atomic mass. Is a serial arrangement. So, just like I mentioned earlier, the scientist Dmitry Ivanovich Mendeleev, a Russian scientist, born in 1834, made and gathered a huge number of elements, finding a pattern. He was looking for a pattern, basically. So he now got the pattern. It's from this pattern that we now have a modern understanding of what happens on the periodic table. He looked at the atomic weights, he looked at their atomic number, and was able to publish it. So it was also when in 1969, there are some things that already predicted their behavior, that at the end of the day came out to be true. And you have different elements. As you discover elements, they slot it into the periodic table. So interesting facts about the periodic table. When the proton was discovered in 1911, it soon became clear that proton number is the key factor in deciding position of elements on the periodic table. Equal number of protons equals to the equal number of protons. Electrons equals to the number of protons. So electrons are arranged in shell, and we know that the shell play a major role in determining the behavior of elements. So the outermost shell electron detects the reaction. So elements with the same number of outer shell electrons react the same way. They react the same way. So how do we classify this element? We already have different classification. The first set of classification that we have is classifying elements as metals and non-metal. We group them as metals and non-metals. As time goes on, you now have metals, you have non-metals, then you have what? The metalloids. Then as time goes on, we now have to still break them down to alkali, the alkaline metals, you have the transition metals, we have the non-metals. The non-metals also have categories, the chalcogens, the halogens, then you have the rare gas metals, which are the ones with the stable electronic configuration. So you look at group 1, you have the alkali, the alkaline earth metals. You have group 2, regular metals, comprised of aluminium, gallium, and every other element. The non-metal chalcogen, halogens. You have the noble gases, also called the red earth gases. You have transition metals, you have the metalloids. Then you still have the lanthanides and the actinides. So this is a picture of different elements. So looking at these elements, you can invariably see. You look at, this is the copper. You have carbon in its characteristic color. You have sulfur. You have phosphorus. You have gold. You have aluminum. All these elements are found in the earth crust. You know, you have your iodine. You have your silver, you have the boron, you have silicon, you have arsenic. So these are different elements. Trying to see them in picture to see how they relate to our everyday life. Then a better understanding of periodic table gives a name and symbol of the element. Yes, the first thing you see is you see the names, you see the symbols. Then sometimes, it is made up of rows and columns. The rows are called periods, while the columns are called groups. So, and there are 8 groups and 7 periods. The columns are arranged in the numerical number using Roman numericals. 1, 2, 8. While the last group, which is named 0, group O, it has filled electron shares. So there is no way you can determine its name, because these elements are named based on their valency. That is, valency is the number of electrons in the outermost shell of an atom. So the number beside each element represents the atomic mass and atomic number. So this is a bigger perspective of elements. So looking at this bigger perspective, you can see that, for instance, you see helium. Helium is used in filling balloons. You look at other elements there for advertising. Neon is used for all those beautiful advertisements. You talk about neon lights used for advertisement. You have argon used for the preservation of bulbs from undergoing oxidation. You see halogens. You see different halogens and what they are used for. Phosphorus used for making matches. You look at chlorine used for making bleach. You look at zinc, sulfur used for treating wounds. You look at different elements. You can see boron used for making sporting equipment. Aeroplane, aluminium is made, the major material used for making body parts of aeroplane is aluminium, because it's light and also heat resistant, mixed with other, to form duralumin. So you see different, a bigger perspective of elements. The reason for this is just to bring out a clearer picture to students that some of these things are real. They are things that you see in everyday life. All the elements are found in the atmosphere, some inside water, some inside the earth crust, and others are found in wood material, found in water, and so on and so forth. So group 1 element are alkali metals. These are very reactive metals. The physical properties for these elements is that they are good conductors of heat and electricity. They are softer than most other metals. And they float in water, low melting and low boiling point compared to other metals in the group. So you can see the reactivity trends of group 1 metals after talking about their physical properties being good conductors, being soft, easily to be caught by metal, having low density and low melting and boiling point. you look at the different trends. Looking at lithium, you see that the softening trend goes down the groove. Cesiums tend to be the very soft metal. Then you look at their water density. So the more you go down the groove, the more dense they become. Understand? But when you also go down the groove, you see that the melting point tends to increase. So you look at lithium. Lithium floats in water. So shoots across sodium shoots across water. That is their reactivity with water. Very reactive, especially group 1 metal, really very reactive. This is a picture of sodium inside water, reacting vigorously with water. They react with halogen, react to form salt. Others, one major characteristic property is that they have one electron in their outermost shell, which, brings about this nature of reactivity. Some can ignite in air, some can react vigorously in air, some can also react explosively in air. So you see the reaction with air, the alkali metal are easily tarnished in air, forming oxides, which end up becoming being reactive with water to form alkaline. When you put litmus paper, it changes red litmus paper to blue. That is why sodium and other group 1 elements are stored under paraffin oil or kerosene oil to prevent it from igniting in air. You see the action with water. They react with water to form hydroxide. They also react with hydrogen to form hydride. Very reactive, very useful hydrides in everyday life. They also react with halogens to form metal halides. They react with halogen to form metal halides. So why does reactivity increases down the groove? Very simple. The reason why reactivity of group 1 metal increases down the groove is because there is always an higher tendency as you go down the groove for easier loss of electron from the outermost shell, because the electron is far from the nucleus. So as the farther the electron is from the nucleus, the weaker the strength of the nucleus to attract it to itself. Despite the fact of the inner shielding of the electrons that is occurring, at the same time, the farther it is to the nucleus, the more difficult for the nuclear pull to take place. So those electrons that are the outermost are easily the electrons are easily removed from the surface, and they are highly unstable. I want you to let you know that francium is the most reactive metal. Lithium is the lightest known metal. So I have a question for you out there. Why do you think metals in group 1, basically that's what we are talking about now, react in similar ways? If you have an answer, you can send it to me and we'll still go further. See you in the next class. Thank you. Bye-bye.